Welcome you all to this Abaqus Python YouTube channel. Once again, this is the Abaqus Python Scripting lecture series, Learn with the Concept, and this is the lecture number 4. In this lecture, we will discuss about the Abaqus data types briefly. And before going further, I'd like to tell you that this will be the last lecture on the fundamental side of the Abaqus Python Scripting, because going forward, we will see some lectures based on the activity based or object based. For example, on the activity side, we might see how to capture the images using the Python script, and how to create animation videos, or how to read the data, or how to create some new contour and write to the ODB. Now let's go ahead. So the first one is the contents. So first we will see Abaqus Python scripting guide. So reading the reference guide is very much important, because as in the last lecture we have seen various types of Python files that Abaqus creates, and those files have various commands written into it. But at the same time, we may not aware of all the commands, so we need some reference guide to be refer to, and that's what we will going to see in this chapter. And next we will see Abaqus data types that Abaqus has added to the Python list. In the brief, we will see mainly three types of data types. Those are symbolic constants and booleans and repositories. And at the end, we'll see different styles of importing the modules. Okay, and how they are different from each other, and how it makes the difference. Now let's go ahead with reading the Abaqus scripting reference guide. So one thing we are familiar with now is we require to understand how to read this scripting reference guide in order to understand the various commands that are written in the various Python files that Abaqus has created. And another aspects of why we should learn how the reference guide is written is that, for example, if you want to understand what all the things you can do with particular object, then all the commands you may not be able to create using the Abaqus CE, because there are some commands which actually you cannot create using Abaqus CE. So for that you have to refer this Abaqus reference guide. Okay, and once you try and go through these various members and methods of the particular object and understand all the methods, what they can do. So if you understand this, you will get an idea what I can do with this object. You'll get a clear idea. You can use that object very much efficiently, and in future if you want to automate something, because of this understanding, you do those things very much efficiently, easily, and you can utilize this scripting capability of Abaqus CE more efficiently. So let's go ahead. So first of all, there are some few chapters they have made, and these chapters are basically made with respect to the functionality. For example, for all the parts related command, you can see clubbed together. The vport command, ODB commands, right? All the commands are clubbed together. Okay, and all these commands are written in the ascending orders. And going further, in each chapter you will see all the sub commands. Those are written into the level of importance. For example, in the mesh command, you can create the mesh on the assembly level and the part level. So that's why these two mesh commands related to assembly level, then the part level, those will be tracked first, and later all the other methods you will see below. And those also, if all these commands have the same importance, then they will be arranged in the ascending order. Okay, now each of these commands are basically object, and for each object, for example, assembly mesh object, you'll have some particular commands. Each of these commands are then again sorted out differently. So for each of this object, you'll see the constructor, and then you will see the methods, and then you'll see the members. So till now we know what are the methods and members are, but I think this constructor we have not discussed yet. So this constructor is nothing but the methods. However, this is the special kind of method that is available. Why it is special? Because these constructors creates the object. For example, if you want to create an ODB, then you have to use a method that creates an ODB, but that method we will call it as a constructor because it is creating that ODB object. Now let's see in some more detail how this object details are organized. Okay, so first of all, you'll see this. Let's take an example of a ODB object. So first of all, you will see some description about the object. Okay, what this object means and what are the details. and then you will see this access. This access is basically is important because this access says that if you want to use this object, what models you have to import, and if some already existing objects are created, then how you can access those objects, that details you can see. Okay, and next you will see constructor methods. Okay, so for example, this ODB object, you need to create, if you want to create some ODB object, then you have to use this particular constructor. Okay, particular method that we call it as a constructor. Okay, and in this constructor you'll see some more details, we call it as a path. Okay, so path is nothing but how you can write these commands, what is the hierarchy order. In the last lecture we have seen the Abaqus object models, right? So how you can use that hierarchy to get to this particular object and create that object. Okay, so first, if any object has some constructor, then you will see these kind of methods organized. But if some object doesn't have a constructor, then you will not see this kind of methods organized like this. After this, we will see other methods that are available for this object, and at the end we will see what are the members and their details, what are the types of information that is stored in that members. We will see that. Okay, now let's see in the Abaqus scripting reference guide how these commands are arranged. So first of all, in the bookmark side, in the left hand side, you will see it is some trees that are being created. These Python commands are very much matured, because you can use this method, Python commands, for the pre-processing and the post-processing as well. But C++ command you can use only for the post-processing. So you can see there are a lot of commands that are being organized here based on the functionality. So let's take an example that we have seen, these ODB commands. So if you click on this ODB commands, you will see all the objects that are related to the ODB data file. For example, this is field output object, then history output object, then ODB frame, then the mesh element. Okay, and other object you can see here. So let's take an example of ODB object, right? So in the ODB object, so you see there is a small description and there is this access. This basically means that how you can access this particular object, what models you need to import. Okay, then we have this ODB method, which is basically a constructor, because it says that it creates the new ODB object, right? One thing we should notice that the first letter of the constructor is always a capital one. In the other methods, you can see the first letter is not capital, it is in the smaller case. But for a constructor, because it is a special type of method, the first letter is always a capital one. So this is one of the check you can do to know what is this a constructor or it's just a normal method. So because this is a constructor, you'll have this path, how you can use this command actually. So you have to write this session dot then ODB. Then we have this other methods. Now we have seen all these methods that are written here, right? And at the end you'll see these members. What are the members for this ODB object that you can see here? And there is a small description also what this particular member stores the information. For example, if is read only is nothing but is the ODB object is opened in the read only mode or not. So that information that is there. Then for example, other data is this step object data, right? Section data, part data, material data. So you can see the description contains the what information it has and how this is stored. For example, this step data, it has stored as a repository. Okay, so repository is a type of Abaqus object that Abaqus has added to the Python list. We will see in a bit what this repository means. Okay, and because you know the data type here, if you want to access this particular member, right, it will be easy how you can go further, because if you understand the particular object, then you can easily access the data and manipulate the data. So that's why this information is important here. Okay, so now let's move ahead, and one important thing I want to tell you here is the different types of arguments that you can give to the methods. And as a beginner, I think this will be pretty much important. Okay, so the methods can be of two types, which basically means some methods require some arguments and some method does not require some arguments. So in the Abaqus scripting guide, how we will know that this object has some arguments or not? Now let's take an example of ODB object methods. So in the here you can see this bunch of methods that are available for the ODB object. Okay, and the methods which requires arguments are given in this fashion. In the parenthesis you will see some dots, 3 dots written, and the methods which doesn't require any arguments, you will see just the parenthesis without any dots. Okay, going further, there are two types of arguments that can give to an method. So some are required arguments and some are the optional arguments. Okay, so as the name suggests, the required arguments that you have to pass, there is no escaping from them. If you do not pass, then you will get error saying that particular argument is not passed. And for this optional argument, you don't necessarily provide the value, but in the background there are always a default value will be set for these kind of arguments. Okay, and all these arguments, this is the one of the important points I want to highlight here. All the arguments that you can see here can be passed as a positional argument or as a keyword argument. So for a new person who do not know what are the positional arguments and keyword arguments are, so here is an example. Okay, so first one is the positional argument. So I am just creating here one viewport actually, and I have to pass some arguments to create this viewport, and I'm using this first one is I'm using the positional arguments. Okay, I'm just giving the value for the particular arguments. I'm not saying that which argument this is I'm passing the value to. For example, I have written here my viewport. Internally we have some particular sequence. In that only we have to pass this argument in order to get the correct results. For example, if you see this constructor in the Abaqus reference guide, you'll see that the first argument will be the name of the viewport, then the position, and then the height and width. Okay, so if I have given in the arguments in this fashion, then Abaqus will infer these values correctly. And the other one is using this keyword. So for example, I have to write what is the name of the argument. Okay, so here the name is viewport name, so I have to write name equals to this, then origin equal to this, and the width equal to this, and height equal to this. Either of these two, you can use any of these style of the argument to pass on. Okay, but one of the problem happens here is generally for the Abaqus methods you have to pass lot of information, and most of the time you may not remember what is the sequence of this or the positional arguments. So there is a high chance that you might mismatch the values that you are passing. So for example, here height and width, right, you can swap these values, and that's why you will get some other results, right? So I would recommend you to use this keyword argument. Why I'm recommending this keyword arguments is, as a new person who will read your script, for him it will be very easy to understand what this information is written. Going forward, if you want to refer your own script, then you may not remember what is the exact sequence that the argument has passed on. But whereas if you have used this keyword argument, then you can directly understand what this value is particularly mean. Okay, I want to discuss here the return value. So whenever you are using any methods on a particular object, it will return something. Okay, and most of the methods return the none object. Okay, and if you are using a constructor method, it will return that particular object that is being created. So let's take an example. So let's say I have open one ODB object here using this open ODB method. Now I want to use particular attribute. So now what I want to know is whether this ODB file that I have opened here, is it a read only mode or not. So whether I can write the data to that ODB or not. So how you can do that? You can use one member that is read only. So it has the Boolean value. It has the yes or no or true or false value that says that whether this ODB is opened in the read only mode or write only mode. So if you are using the members like this, it will return some Boolean value, as I said, right? So this return value you can use in this fashion. So that's why this return has its importance. Okay, now let's see some data types. So what Abaqus scripting interface has done is it has added over 500 data types, different data types, into the already existing Python list. Okay, so these are specific to Abaqus. We will discuss here only 3 types of data types, and you might wonder what about the other remaining data types. So those are already covered in the Abaqus scripting reference guide. So previously we have seen how this Abaqus scripting reference guide is arranged, right? First of all, we will have the chapters, then inside we will have the objects, right? And that's why the methods and members related to these objects are already covered there. But the objects or the data types that we are going to discuss here are not specifically covered in those reference guide. So that's why it is important to discuss this separately. Okay. So first of all, we will discuss the symbolic constants. So what are the symbolic constants? Are nothing but the some specific constant that has Abaqus has added. And to use this constant, we have to import one statement, that is Abaqus constants. Okay, so this model we have to import, and some of the examples are like when we are defining or creating any part, we have to define the dimensionality of that part. For example, this is a 2D object, 3D object, something. So this we can specify using this symbolic constant. So there are three different symbolic constant that are there in the Abaqus. So one is the 3D, then 2D planar, and then this axis symmetric. So you can see these are the all capital lettered values that we have to give as a argument. So this is one data types, and the other one we will discuss here, the booleans. So in the Python we have some booleans, right? You might already aware. So the booleans that there in the Python is true or false. Only these two booleans are available, right? The booleans that Abaqus has added are derived from the Abaqus constants. So similar to the Abaqus constant that we had seen previously. So two different booleans that Abaqus has added, and again that's why we have to use this import statement. And what are these two booleans that Abaqus has added is on and off. Okay, and the last data types that we are going to see here is the repositories. So what are the repositories? So these repositories are used to store the similar kinds of object. For example, we can see here the field output, all the field output objects, all the frame objects, all the step object, all the node object, all the element object, all those things are of the same type, right? So all the objects are will be stored in the repositories. Okay, and these repositories are more like a dictionary. But in the standard dictionary, a Python dictionary object, you can store all kinds of value to it. But here we have to store only the similar kind of object. So that is the difference. So these repositories, how you can access particular object. Let's say we have some repository which has all the similar kind of object. So how we can access this using these key values or the index values. Okay, so depending on the type of object, it stores this varies. So for example, if you want to access the step data, then you have to use the key. This key refers to the name of the step. Then if you want to access the frame, then you have to use the index. So not the string value, but the index value we have to use. And if you want to access the field output, then you have to use this key value again. Okay, and there is this method using which you can change the name of the particular object in it. For example, you have to use this change key method in order to change the name of the object that is stored in the repositories. Okay, and the last point we are going to see here is the different styles of importing the modules. Okay, so previously I think we might have seen the importance of module, why they are important, because we can use this already existing code for our purposes without adding into the main script and making our main code little bit less cumbersome. Okay, so there are different kinds of importing styles, but first very briefly want to just tell you what are the namespaces means. If this is not clear here, please go through and read more about it. Okay, so basically the namespaces are some system that has all the objects named uniquely. Okay, so for example, in the model you have created some objects, right? Those are some unique names that module has. So all the objects and methods, right, all are specific to that modules. So you cannot use them directly. How you can use those objects and methods is you have to import those objects and methods available in that namespace into the current namespace. First way of importing any module is import then the module name. So here we will use this funds. So if you are using like this, what you are doing basically is you are bringing in all the objects from this funds.py module via the namespace funds. Okay, so going further we will see some examples related to it. Okay, And if you're using this kind of statement, from funds import this square. Okay, so this square is nothing but some object or some method. Okay, what happens in this case is you are directly bringing in that object, this in this case the square object, into this current namespace. Okay, so in the first way you have to use this reference of funds to access any object in that module, funds module, but here you are directly importing that object in the current namespace. And the last one is using this star. So from the funds import star. So star means import all the objects from this funds module into the current namespace. Okay, so we will see this different styles of importing modules with example. Now let's see different importing styles with the example. Okay, so first one we will see here is the import funds. Okay, so here we have seen, right, so if you are importing a module something like this, so before that let me just show you this funds file, what it has. So it has basic two functions I have created. One is this square, with basically doing the square of a arguments that I'm passing here, and the other one is the cumulative sum. Okay, so there are two functions. So if importing a module something like this, what happens here is we have seen, right, we are importing all the objects from this module via namespace called funds. Okay, what this basically means is I can use all the objects that are there in the funds module, but I have to use the reference. Okay, so how that works is, if I want to use this square function that is there in this file, right, I have to use the reference. So how that I'm going to do, I used to use this funds, then dot. Okay, and then I have to use this function. Okay, and pass the argument as required. Okay, and what happens, if I have created some variable who is already available in that module. Okay, so let's run that and just see what's the results are. So the first one, it has run correctly, so it has a squared. Okay, and when I'm running the function second time, that time also it's running it correctly. Okay, so it seems to be, when I'm using the same name as the variable available or function available in the module, it is not seems to be affecting. Okay, so and same thing about sum function, cumulative sum function. So same thing, I'm using the reference here. Okay, so let me just comment this one and let's focus on the second one. Okay, so second one is what I'm doing here is I'm importing the square function or object directly into this namespace. Okay, so what happens, let's try to run this. Okay, so it has given some error, but let's see. So first of all, what it has done is it has run this function correctly, right? And this time, because I'm not creating any reference to those objects and functions inside this funds module, so I can use them directly, so there is no reference required. So if I just need to write this square name and that's it. But now what I'm doing, I'm changing the value of this function. Okay, this object. So what happened here is now this square at this line, it is no longer a function which we have defined here. It is now a integer. Okay, and so that's why it's giving me an error. So the error is also intuitive here, the type error, int object is not callable, so we cannot call an integer object. And the last error is, you can see here, is the sum variable is not defined because we have not imported that one here. It is available in the funds module, but we have not imported in this namespace, in this main namespace. Okay, so that's the one difference. Let's use the last one now. So for the moment I have just commented this one. So now in this construct it is the same as the previous one. Instead of importing any object or function one by one, I'm importing all the objects directly into the current namespace. Okay, so in this case, all the functions are running correctly without having to define the reference. Okay, so now let's see, if I change the value of the function once again, then what will happen here again, it will throw me an error. Okay, because I'm modifying the function that is there in this funds module. So you see there is a one big problem while importing the objects directly into the current namespace. I hope you might have understood this problem. The problem here is I have to be very careful that I should not modify any of the objects that are there in these modules if I'm importing the module in this fashion. Okay, but if I use the this nomenclature or this style, I don't have to worry about it because I'm using here one reference, right? So that is the important point here to note down. So always try to import the modules in this fashion because it is very much take care of the errors of modifying the function values or object value that are there in this module. Okay, so that's all from this lecture, and as I said in the earlier part of the lecture, this will be the last lecture on the fundamental side. So going forward we will see some activity based lectures, and so for that please comment or suggest me some topics that you want to understand more about it. Let it be any queries, and if you are liking this series, please show your support, like it, share it, subscribe it, and most importantly give me some suggestion on the next topic you would like me to cover. Okay, so that's all. So stay safe, be hungry to learn. See you, bye, and tata.